Hello, physics. The question is about the prism and refraction. And the question says that what is the critical angle when a light ray is traveling between two media, glass and air? Calculate the critical angle between glass and air interface when uh, refractive index is given glass 1.49 and air 1.0026. Following the diagram, Ng glass refractive index 1.49, apex angle phi is 60 degree, and the ray of light emerging from air is incident on the surface of point A, this one, at an angle of theta 1, this is theta 1, and refracted into glass at the surface of point B, this one, at a critical angle theta C, calculate theta 1. So here the angle of incidence is such that it is reflected back into glass. So this is a critical angle. So we have to find theta 1. So first of all, define the critical angle. A critical angle is the incidence angle above which the corresponding refracted ray is deflected into the medium. So this is the ray which is deflected, instead of going out, is deflected into the medium. Or angle of incidence when the refracted angle is 90 degree. So it's like this one. It is the glass and this is air and this is entering. Instead of refracting into, it is 90 degree, and if you increase this one, and then it will go down, come down into the medium. So A is so question 2. A is uh, A and B. So incident and this is refracted. Applying Snell's law at point M. So Ng into sine of entering angle, entrance. Sine theta C is equal to N air emerging. And so sine of 90 degree into the sine 90 is 1. So this will be equal to sine of theta C is equal to NA over NG, or just sine theta C is equal to inverse of the sine and A arc sine and A over NG, which is 42.2 degrees. That's a very good question. And part 2 is slightly difficult, but it's not so much difficult. You consider the diagram. This is a red line is incident, and then it is went into the medium, glass medium, and then is reflected back into the medium. So this is theta 1, this is theta 2, this is 1 angle, this is 2 angle, this is theta C, and this is beta, and this is apex angle phi. So we consider A point. If A point theta 2 plus 1 is 90 degree, B point 2 and theta C is 90 degree, and then C point is here, theta C plus theta 2 plus beta. So theta 2 plus theta C plus beta is 180 triangle. And then D point, this is a D point. D point, if you consider D point, 1, 2, and phi is equal to 180 degree. So applying Snell's law here, applying Snell's law, air to glass. So air to glass, NA sine theta 1 is equal to Ng sine theta 2. So theta 1 we have to find. So theta 1 is equal to arc sine Ng over Na over to sine theta 2. So that means we have to find theta 2. So equation 1 and 2 join together, 1, 2, because the theta 2 is here or here or here. So theta 1, theta 2 plus 1 plus theta C plus 2 is equal to 90, 180. And then we have this equation, equation number 4. Equation 1, 2, 5 is equal to 180. 1, 2, uh, uh, subtract this one. 1, 2 cancel, 1 cancel, 2 cancel, 180 cancel. Theta 2 plus theta c minus 5 is equal to 0. Or theta 2 is equal to 5 minus theta c. So that's it. If you substitute this value into this one, then you will get theta and arc sine ng minus ng over na into sine phi. This is theta 2, phi minus phi theta c. Phi is given 60 degree, and this is we have just calculated 62.2 degree. So if you ng is 1.49, air is 1, so we will get 27.1 degree. This is the answer. So the incidence angle should be 21.7 degree. Then the ray will be uh, reflected back into glass. So it will be a critical angle. So this is the answer.